enter. At this point we're set, we're recording, I mean, so
Okay.
now it's a matter of actually beginning what
Yes.
we're going to do. So we're going to create a source file for, we're going to call it objmit, and it's going to be in C language, so .c, okay, and we're just going to get started basically. We're going to have the standard input-output library, lib, which is just standard library stuff. Pthread is basically a threading library, which we're going to need because we're going to use threads running a kernel. That's going to be basically how the composure of this program is going to be. Now we need to decide basically how the number in X and Y of objects we want to be able to emit. We're just going to do 20 by 20. And the number of threads basically is going to be, we're going to have one thread for each object that's going to be emitted, so we're going to do mbx times mby. Okay, and the size of the construction of the objects, we're going to need basically a width, a height, and a depth. And we're going to do some randomization basically with how much space, this amount, in the width. And
Just to prove it happens to anyone.
yeah, the width, the height, the depth. Okay, so we're going to define some structures that are going to be the composure, used to compose, I guess, our objects. So we're going to have vectors of integer type, floating point type, and so on. So we're going to have the I for the integer type, and we're going to spell it German spelling so we know it doesn't collide with anything that might have vector somewhere else. So this structure here is going to store two components. So I have I vector 2, they're integer components, and there's an x and y. We're going to call this thing an I vector 2. I want to spell it English spelling. Now we're going to do a floating point vector of 3 dimensions. And we're going to call that one, surprisingly, f vector 3. Okay, so now we're going to have f vector 4, which is, we could actually do 1, 2, 3, 4, 5 line copy and paste, and we'll just change this to 4 and this to 4, and then we'll add another one, a W component. Okay, so I have that structure. Now we need a structure basically that has 3 things, of which each of them is an f vector 3. Okay, so we call that TRS for translate, rotate, and scale. So those are the basically vector to represent each of those manipulations. So each object will have one of these associated with it, which defines how it's positioned in the world. Now pthreads basically requires us to specify a structure that you're going to pass to the thread. So this is going to be the structure we're going to use. We're going to have an index, we're going to have an I vector 2 xy coords, which is going to be basically the coordinates of in object space that this thread is. So basically each thread will be told which object it needs to emit in the grid. So there's also going to be a translate, rotate, and scale, which is what that thread is going to be computing. So that's our brick thread arg. Okay, so now we need to write the kernel function that's basically, we're going to pthreads launch. And so that needs to be void star, is required. We're going to call it brick thread, we can call it whatever we want, but we're going to make objects of type brick basically, so this will be a brick thread. Okay, so we need void star basically input argument, which we'll have to cast our brick thread arg thing to this, but that's what we'll be handing in. Void star is just a pointer to arbitrary typed things, but you can tell what type of thing you want when you pass it. Just make sure you cast it as void star and cast it back. So in that vein, we need to basically have an argument, brick thread arg, and we'll basically use this pointer to brick thread arg as a casted copy of the void star thing. So that basically converts A into be that type, and then we can access the components in it. So now we want to do something. We want to write the position t value x to be we practically everything, all the data that we have comes from this d, so we look it up, xy coords dot x times, and then basically we'll use those constants we set up earlier, the brick width and the grid width, I guess, the gap, whatever, the little space in between the bricks. That's not grid, I mean it's gap is what it's supposed to be. I don't know why I want to say grid, but yeah. So then we'll add a random width scaled random value. So we need to create a random value from rand, which should be in stdlib, which we included earlier, hopefully.
Should be in what?
Stdlib. It's the stdlib is this thing that we included up here.
Oh, okay.
We included it, so I mean, if we do man rand, we can see what it requires, but we can see at the top it requires stdlib, which we have, so we can use it. We'll have to run srand basically in order to use rand, but we have to set that up in main. It's fine. We'll have a seeded random number generator happening. So, okay, so we've got our random value. We converted it to a floating point. I need a close parenthesis there. And then we divide it by a floating point converted copy of the maximum value, which is from, it's basically the biggest random number that it could give you. So basically you've scaled it into be a value between 0 and 1, which we're going to use to pick into the random width which we have set up. We're going to be using this construction a lot for each of the depth and width and height. Okay. So we practically have to do the same thing. We just pick a different randomness to put each of the positionings. So then we're going to add xy coords dot y plus times, okay, so times the brick's height plus its the gap's height. Okay, something weird. I'm doing something weird. Okay. What I need to do is, because basically the bricks, every other layer of the bricks needs to be set off from one another, because you don't want the bricks to fall out just like every brick is sitting on top directly of another brick. You want every other line to be slightly offset.
Yeah.
So we need to basically decide every other time to put half off of the brick width. Okay, so now we basically will go on to the next position. So we did the X position there, so we'll do the Y position here. Now we'll do our random construction, except for we'll do some slight differences. We're not going to have that other component on this one because this one's not even done that way. Hopefully I got my parentheses matching. We have an open. I've got too many parentheses, I think I had too many up there anyway. I don't have an open parenthesis here because I had to have the cast inside parentheses for that. So I think we're okay. Sorry, I'm making a mistake. So pos t dot z. That's supposed to be the translate component. Okay, so these are all the translate component. I'm making typos. We're just going to basically do a random value here, so we can actually just copy this construction. So then we'll have this thread exit. Okay, so now we need to basically create the pool of threads and the data structure, basically the memory locations where the pool of threads, pthread t basically. And then that's the number of threads.
Thread pool or thread pool?
Thread pool. It's supposed to be a thread
Okay.
pool. I got a serious mistake. Okay. Big thread arg data. Okay. Of the number of threads. So we have a space to store each of the argument values and a place to store how basically the threads are enabled for use, and pthreads basically requires that structure for every running thread. So create one for you. You create an array of them. So now basically we need a main function, and we need to pick up the pace. We want to hit 15 minutes.
Yeah.
Which we probably won't hit, but I'm going to try for it anyway. We'll see the random number generator off of time of 0. And, okay, so, yeah, I mean, I feel like I should just give up at this point, but
No, just
stop and start another video. I still need to type out a main function, so
well, just bring that as the closing for this particular.
we'll save it. We've got something here.
Yeah.
We can write a make file, and then we can come back and finish that. Okay, so the make file, we'll set up the target is objemit. We'll set the C compiler to C99. We'll change the options to -02 and flags to be -W all for all the warnings and pedantic. And we'll set libs to be -LP thread. Okay, so now the target comes from the target.c, and you run the C compiler with the options, with the flags, with the libs. Set the output file to be the target and the input file to be the targets.c file. Okay, and we'll have a clean target to rm-f the target.
9, 8,
And we'll save the make file. Okay.
All right, home clear.
Let's stop that.